So okay guys, today we will solve the first missing positive integer in Leetcode. So it is given an unsorted integer array nums. You have to return the smallest positive integer that is not present in nums. So you must implement an algorithm that runs in order of n time complexity and that uses order of one space complexity. So let me consider this nums array. One is will be available here, two is available here, so 3 will be not available. So it is the first smallest integer that is not available in this nums array. If you consider this nums array, 1 will be available here, but 2 is not available in this nums array. So you have to return answer as 2. In this array directly 1 is not available, so you have to return 1 as the answer. So if you consider the nums dot length, I mean maximum length of n will be 10 power 5. So and also the elements in nums array consist of both positive and both negative also. Now I will explain through one example, then you can easily understand this problem. So imagine you have a list of numbers, but some are missing. Your job, find the smallest missing positive integer. Sounds simple, right? But what if I tell you we need to do it using the most basic approach before diving into optimized solution? So let us consider this nums array. It consists of different elements, but in unsorted array manner. Here k represents the initial positive integer. It will start with 1. So I will check whether 1 is available in this nums array or not. If it is available, now I will increment with 2. I mean with 1. Now I will again check whether the 2 will be available. Yes, it is available. Now I will increment with 3. Now I will again check whether 3 will be available. Yes, it is available. So you can increment k with 1. Now I will again check whether the 4 will be available in this nums array or not. Yes, it is available. Now I will increment with 1. So it will becomes 5. Now I will check whether this 5 will be available in this nums array or not. No, it is not available. So your answer may be become the 5. In the brute force approach, we are trying to find the smallest missing positive integer by checking numbers sequentially from k equal to 1 upwards until we find one that is not in the array. So what are key observations in this approach is the smallest missing positive integer must be within the range of 1 comma n plus 1. So where n is the length of the array, the worst case scenario is when the array contains all the numbers from 1 to n exactly once, like 1, 2, 3, 4, 5, 6, 7. So the k, if all the numbers from 1 to n are present, then the first missing positive integer is must be n plus 1. Why? Because it will check initially it has 1 and 2 and 3, 4, 5, 6, 7 now. So it will check all the numbers and it will goes incrementally up to the maximum length of the this array. Okay, let me analyze the time complexity for this. The time complex for this approach is n into k, where k can go up to n plus 1. So 10 power 5 into 10 power 5, because here the length can maximum length of the nums array it will be 10 power 5. 10 power 5 into 10 power 5, it can 10 power 10. So is it work for our solution? No, it doesn't work. So our solution must be 10 power 8. So let me optimize this solution uh, into further. Let what if I sorted this nums array, so it will take order of n log n. Now again I will check whether one is present or not. If available, now I will increment with 2. So it is also available, so I will increment with 3. And 3 also available, I increment with 4. and 4 wheels are also available. No, I increment with 5. If it is available in this nums array, no, it is not available, so you have to return the answer as 5. In this approach, the time complexity will be n log n for sorting, and for n uh, to checking the k, and 10 power 5 into log of 10 power 5 plus a 10 power 5. So 10 power 5 into 5, because log it will be preceding now 5 into log 10. So, and so maximum among this one is 10 power 5. So maximum time complexity will be 5 into 10 power 5. So it will work. But in this approach, the time complexity will be maximum of this one, n log n. So what here mostly the time taken by this algorithm is we accessing the particular element in nums array. So we can reduce it by using hash map now. So a hash set or hash map allows the order of one lookup time for checking if a number is existing or not. So we first store all the numbers from array in a hash set or hash map. So then we iterate from 1 to n plus 1, checking for the first missing positive integer. So here let me consider this one is a map, and first you have to insert all the elements of nums into the hash map, and iterate from consider by using k equal to 1. Now iterate from 1 to n plus 1, checking which number is missing in the hash map. So the time complexity for this by using hash map is n plus n. For here n will be taken by the hash map to insert all the elements, and here mostly here n will be for the mostly k. So without any delay, let me do code for that one. So here in this case, let me write the code for this one. So let me take okay, let me write code for this one. Let me first initially find out the size of it will the size of the enums array, it will be n. Now initially I will initialize a map for every element in nums array. I will initialize with that one. Now I will find up to when up to I plus 1. I will check for that particular element is present or not. For our simplicity, I will consider it as k, because we in this approaches we consider this one as k now. So if m dot, it can tell whether it is element is present or not. If it is present, our logic is if it is not present, then we have to return the answer. So if not equal to, then you have to return the key element. So generally it is not required, but it is int boolean. You have to return the 0, because it has int. Definitely it can give error in lastly, because it has a non-void function and does not return any value now. So it will be accepted. Mm, yes, it is 100%.